Hello. In this section, we will study about Plesnar's line algorithm for all type of slopes. So before we consider there is a Plesnar's algorithm, that is a drawing algorithm. So just this is the algorithm for Plesnar's. So step 1, that is we are going to read the endpoints, that is x0, y0 and x1, y1. Okay, so that is read two endpoints of the line. Okay, first we are going to plot, that is x0 and y0. Then it needs, that is we have to calculate, that's a dx means that is a x2 minus x1, and dy delta y, that is y2 minus y1. Calculate 2 delta y and 2 delta y minus 2 delta x, and we should consider the initial decision parameter, that is a p0. So it equals 2 delta y minus dx. Okay, so at each xi along the line, start with, that is a k equals 0. Okay, so we have to repeat. What we have to repeat? Check if what we are going to calculate, there is a p0 value. So if pk is less than 0, what is the next point? Next point is, that is xk plus 1 comma yk, and we have to get the next decision parameter, that is pk plus 1 equals pk plus 2 delta y. Otherwise, else if it is not equal, it is not less than 0. If it is greater than or equal to 0, so next point is xk comma yk plus 1, and next decision parameter, that is pk plus 1 equals pk plus 2 delta y minus 2 delta x. Okay, so here we are going to repeat the step, that is a 4. Repeat the step 4, that is dtx minus 1 times. Okay, so that's we consider how we are going to implement this algorithm. So first we are going to read the 2 parts, that is x1 y1, x2 y2. So these are function, that's the definitions. Resize for window, that is next is set pixel. So in order to set the pixel, we are going to pass two parameters, that is of type integer. So next we have to calculate the slope. So that is when there is a slope is less than 1, that is we are going to call this function, that is line Plesnar's less than 1. We are passing x0, y0, okay, x1, y1, and we are going to pass the, that is a m value, that is a slope. Similarly, that is if that is slope is greater than or equal to 1, again we are going to call this function, that is line Plesnar's greater than or equal to 1. So passing, that is x0, y0, x1, y1, and that is the slope value. So come to the, that is a main function. Okay, first it will display Plesnar's line drawing algorithm. So next, enter the starting vertex, that is x1, y1. Read the two values, that is x1 and y1. So next, enter ending vertex, that is x2, y2. Read x2, y2. Okay, glut init, that is a, if passing any command line arguments, it is initialized with, that's a, what are the values passed in command line. Next, glut init display mode, that is we have to use, that is a glut single or glut grb. So here glut single indicates that we are going to make use of a single buffer for RGB component. So that is we are going to specify the color, that is a glut RGB. Glut init window size, that is 400 comma 400 width into height. Set init window position, that is just consider it is a 80 comma 50. So it's going to start with x-axis, that is a top left corner, that is a just consider is 80, and y, that is a 550. Glut create window, this will add the header Plesnar's line drawing algorithm in the title bar, and it will open a new window which is of the width 400 and height is 400. Glut display function, that is a display. Here we are going to display all the graphics elements onto the screen. Glut reshape function, that is we are going to call the function resize. That we have to execute, that is a glut main loop, it will start executing the main function. Okay, so just consider there is a resize function when there is a aspect ratio is changing, that is we have to resize the window, that is int w and int h. GL matrix mode, that is we have to get GL projection. First we have to draw the objects onto the window, so we said that is a GL projection. Then load GL load identity, so this will load the identity matrix. Glue ortho 2D, that is 0 dot 0, that is a width. This is called x position and width, and this is the y position and height. Similarly, that is we have to check get the, there is a viewport GL viewport. Okay, same, that is it is same size as that is the ortho 2D, that is what is projection we are setting. The viewports should be same size, otherwise that is the object display which is not visible which is outside, that is a viewport. So we are going to set the same as that is a the 2D projection and the viewport. So next concept, there is a display function. So in display function, first GL clear, this is used to set, that is a background color, that is what we are going to set within the bit buffer bit, which is going to change, there is a background color will be changed, what is the color value set into this buffer. Next get, there is a GL float m value, we have to calculate the slope value. m equals, that is y2 minus y1 divided by x2 minus x1. So check if there is a float absolute of m value which is greater than or equal to 1. That is greater than or equal to 1. So we are going to call line bless underscore g minus 1, that is indicates greater than or equal to 1, passing that is x1, x2, x1, y1, x2, y2 and slope value. Else we are going to call line distance, that is a less than 1, pass x1, y1, x2, y2 and that is a slope. Okay. Next consider, that is resistance if it is a slope is, that is a less than 1. Okay, so line resistance, that is a L, that is L1 less than 1. So passing x0, y0, xn, yn and the value of slope m. So just calculate, there is a dx value. Dx is xn minus x0, dy is yn minus y0. So initial parameter, that is p equals 2 delta y minus delta x. Similarly 2 delta y equals, that is 2 delta y. 2 delta y minus dx equals 2 delta y minus delta x. So initialize the values, that is x equals x0 and y equals y0. That is, we have to consider either we can draw the line from x0 to, that is xn, or we can draw the line from xn to x0. So here first we are going to consider if x0 is greater than xn. Okay, so just consider x0 is greater than xn. So we are going to make starting point as x equals xn, y equals yn and xn equals x0. Else keep as it is, x equals x0, y equals y0. Then we are going to call that is a set pixel. What is the first pixel we are going to set onto the screen? Next, while x is less than xn, we have to repeat in the while loop, that is x is incrementing sequentially. Now we have to calculate the y value. So check if p is less than 0. Okay, so next p equals p plus 2 delta y. Else if p is not less than 0, check if slope is less than 0, decrement the value of y. Else increment the value of x and increment the value of y. Then calculate p equals p plus 2 delta y minus delta x. Okay, after that we are going to set the pixel. This loop will be repeating until the x is less than xn. Once it reaches the xn, it comes out of the function. Okay, similarly we consider, that is if it is greater than 1, it is similar to that is less than 1, just we have to interchange, that is a values, that is we have to calculate, that is if is x, y here, that is if it is less than 1, x is incrementing sequentially and we have to calculate y value. If that is slope is greater than or equal to 1, y is incrementing constantly and we have to calculate the x value. Okay, so that is line resistance greater than or equal to 1, pass the values x0, y0, xn, yn and slope value m. Just calculate similar to that. We have to calculate, that's delta x, delta y and initial parameter. Okay, 2 delta x and 2 delta x minus 2, that is a minus dy. Okay, so initially the same parameters, that is x equals x0 and y equals y0. Check, that is if y0 is greater than yn, x equals xn, y equals yn. And yn equals y0. So here that is similar to I said in, that is x0 is less than xn. We are going to interchange the points. Okay, else x equals x0, y equals y0. Set the initial where there is a pixel x comma y and we should repeat the loop, that is y is less than yn. Repeat, increment the value of x. If p is less than 0, p equals p plus 2 delta x. Else if consider, that is if m is less than 0, decrement the x value, else increment the x value. Calculate next decision parameter p equals 2 delta x minus delta y. Set the pixel. Okay, this is what that is a greater than 1. So similar, that is considered both the equation, there is a function less than 1 and there is a greater than 1. Okay, so it's here there is not, that is a difference is, that is we are going to consider if that is we are interchanging the x and the y values. Okay, so set the pixel, first pixel is set. So here we are going to repeat. Okay, so in greater than 1 we are going to repeat from y to, that is a yn. Here we are going to repeat for x to xn, that is we have to calculate here x y value. Here we are going to calculate the x value. Okay, consider the same. So that is if p0 is less than 0, p equals p plus 2 delta y, here 2 delta x. So here that is else, check the slope if less than 0. So here we are decrementing the x, here we are decrementing the y value. else increment the x value, increment the y value. So again we have to calculate p, this decision parameter p equals p plus 2 delta x minus delta y. Here 2 delta y minus delta x. So this is only the part which is repeating until we reach the end point. Okay. So next consider a set pixel. So how to set the pixel? First we have to specify GL begin, that is GL points. So we have to specify GL vertex 2i. 2i indicates we are passing two parameters of type integer, that is set pixel. So x and y of type integer. So x coordinate, y coordinate, GL end. Okay, this will set the particular pixel at particular position. Okay, so GL flush. So here GL flush indicates that all the operations that is within the queue or that is executed completely. That's a GL flush.